As we said, acceleration is the change in the object speed in 1 second in a specific direction. So what uniform acceleration means? Uniform acceleration, it means the change in the speed with equal volume in equal period of time. Let's remember when we talked about uniform speed. Uniform speed, it means the body covers equal distance at equal period of time. While uniform acceleration, it means the change in the object speed decreases or increases by equal volume at equal period of time. This is called uniform acceleration. Uniform acceleration is the acceleration by which the body moves in a straight line, which its speed changes by equal volume in equal period of time. So when the speed changes, we said this is acceleration. When the change in speed with equal volume through equal period of time, we say uniform acceleration. Okay, what's meant by a car moves at a uniform acceleration equal 5 meters per second squared. Here, concentrate uniform acceleration, not acceleration only. If the question acceleration only, yes, we will answer. It means the speed of the body changes with 5 meters per second in each 1 second. While here, uniform acceleration, it means the change in the body moves in a straight line when its speed changes 5 meters per second each 1 second. Types of uniform acceleration. If the change in speed increases, it means positive acceleration. Let's see. When the body starts its moving from rest in a straight line, when the body starts moving from rest, so its initial speed is larger or smaller? Yes, smaller than its final speed as it starts moving from rest. Here, the table, when time 0, the speed 0, because the initial speed is 0. And the body starts moving from rest, concentrate. And the speed increases. Speed increases, it means, yes, changing speed, acceleration. When the speed increases, it means when we, for example, 5 seconds, the speed changes to 10. 10 seconds, the speed changes to 20. So the changing in the speed, it means acceleration. When the change, the V1 less than V2, the final speed is 50 meters per second, while the initial speed is 0. So the initial speed is less than the final speed. Here we can say this is a positive acceleration. Let's see the graph. The graph, we will draw speed on the y-axis and time on the x-axis. Here, the graph represented by a straight line passing through the origin. While here, the graph speed and time, speed meter per second and time is in seconds. We can say this type of acceleration is a uniform acceleration because the changing speed equal value in equal period of time. While here, when the initial speed is smaller than the final speed, we can say this is a positive acceleration. If I want to calculate the acceleration here, from the table or from the graph, the initial speed is 0 and the final speed is 50. What's the rule for acceleration? Yes, acceleration equal delta V, V2 minus V1. Don't forget. V2 minus V1. V2 is the final speed. V1 is the initial speed. V2 50 minus 0 and the time is 25. We have time 25 equal to meter per second. If you observe here, we put positive. Positive, it means the sign positive refers to the speed of the object increases by 2 meters per second in each 1 second. So the increasing and the changing of speed is regular. Each 1 second, the speed increases by 2 meters per second. This is the positive acceleration. Negative acceleration. It's the second type of uniform acceleration. It means the object moves with 50 meters per second and then the object speed decreases until it stops. So here the initial speed is 50 and the final speed is 0. As you see in the table, the initial speed 50 and the body moves with 50 meters per second. And then the speed decreases till reaches to 0. So the body stops. This is the type is called negative acceleration because the changing in the speed by what decreases. The speed decreases 50, 40, 30 till reaches to 0. The graph here presented by speed and time graph. The speed is what? Yes, it's completely different for the positive acceleration. So we have two types of acceleration, positive and negative. If I want to calculate acceleration from this table or from the graph, acceleration v2 minus v1 over delta t. v2 equal 0, yes, while v1 equal 50 because the speed decreases. So 50 is the initial speed. The result will be negative 2 meters per second squared. Don't forget the measuring unit, meter per second squared, as we calculate acceleration. Negative sign means the decreases in speed by 2 meters per second in each 1 second. So students, here we have two types of acceleration, positive acceleration and negative acceleration. In positive acceleration, the change of the speed increases by equal volume through equal period of time. While in negative acceleration, changing decreases by equal volume through equal period of time. Let's compare between positive and negative. In positive acceleration, the initial speed is less than the final speed. While in negative, yes, the opposite. Final speed is smaller. So the initial speed is larger than final speed. Here, when the body moves from rest, so the initial is smaller than final. While here, when the body moves with any speed and then the body stops, so the final speed is smaller than the initial, and initial is larger than final speed. Okay, positive acceleration, it's the acceleration or when the speed changes by increasing or decreasing. Yes, when the speed increases by equal volume through equal period of time. While a negative acceleration is the acceleration when the body moves in a straight line and the speed, yes, decreases by equal volume through equal period of time. Okay, here, what's meant by? If the object moves at a positive acceleration, please concentrate in what's meant by questions. Here, you have to focus on the words that help you to answer the question. An object moves at a positive acceleration. First of all, acceleration means there is a change in speed. Positive acceleration, yes, the changing increases. Okay, so we will define positive acceleration. What's meant by positive acceleration? It's the acceleration when the speed changes, yes, increases or decreases, increases. This means the object moves in a straight line when its speed, instead of changes, we will write increases, as it's a positive acceleration by 2 meters per second in each 1 second. Don't forget, we have to write meter per second because we talk about speed. Okay, on the other hand, when we talk about negative acceleration, what's meant by an object moves at a negative acceleration equal negative 2 meters per second squared. Yes, the same. We will write the definition of negative acceleration. Okay, this means the object moves in a straight line when the speed, instead of changes, we will write decreases. Yes, because this is a negative acceleration by 2 meters per second in each 1 second. Here, the graphs represent acceleration. When zero acceleration, when the body is zero acceleration. What's meant by zero acceleration? Acceleration means the speed changes. When the body zero acceleration, it means the body moves with, yes, a uniform speed. When the body is zero acceleration, it means the speed is constant and doesn't change. So the speed and time graph, do you remember when we talked about uniform graph, speed and time graph, a straight line parallel to the time axis. It means a uniform speed, there is no acceleration. The object moves a uniform speed, it means V1 equal V2, and the initial speed equal the final speed. While when the body moves with a positive acceleration, this is graph for positive acceleration. Don't forget, with speed and time, the graph represented by a straight line passing by the origin, it means positive acceleration. When the object moves a non-uniform speed, acceleration. When initial speed is smaller than the final speed, it moves with a positive acceleration. Negative acceleration, this graph for negative acceleration. These graphs are very important, okay? Please concentrate. Negative acceleration represented by this graph when the initial speed is larger than the final speed. Okay, now let's solve some problems on acceleration. An object moves from rest and its speed reaches 2 meters per second. Okay? When the body moves from rest, yes, it means V1 equals 0. Speed reaches 20 meters per second, it means V2 equals 20 meters per second. In 5 seconds, this is the time. Calculate first the acceleration of the moving body and then what is the type of the acceleration. Okay, let's solve the problem. V1 equals 0. Why? Yes, because the body moves from rest. So V1 equals 0. V2, 2 meters per second, and the time 5. We will write the rule. Acceleration equal V2 minus V1 over delta T. 20 minus 0 over 5 equal 4 meters per second squared. Please don't forget the measuring unit. We calculate acceleration, so the unit is meter per second squared. This is positive acceleration or negative acceleration. Do you remember the sign positive and negative? Yes. And also, when V2 larger than V1, it's positive acceleration. When V1 is 0, the body starts from rest and then the speed increases and reaches to 20. It means positive acceleration. While when the sign is minus, it means negative acceleration. Don't forget, we have to answer all points in the question. Another problem. A train moves at uniform speed of 20 meters per second. When the driver uses the brakes, the train stops after 4 seconds. Calculate the acceleration at which the train moves and mention the type of acceleration. Let's see. V1 equal what? Let's see. Uniform speed 20 meters per second. It moves with the speed, so it's the initial speed which is 20 meters per second. When the driver uses the brakes, it means the body or the car, the train, whatever, will stop. So V2 equal 0 and time 4 seconds. So acceleration V2 minus V1 over delta T, acceleration, the initial speed 0, no, it's final speed V2, and 20, it's V1 because the body moves with the speed 20 meters and then brakes is applied. So V2 equal 0. The result will be negative 5 meters per second squared. Don't forget the measuring unit. Negative refers to positive or negative acceleration. Yes, why negative acceleration? Because the speed decreases till it reaches to 0. Okay, here, a car driver moves at speed of 80 meters per second. Use the brakes to make the car move at a uniform decreasing acceleration, 2 meters per second. It's a very tricky one, okay? When decreasing acceleration 2 meters per second, we have to add what here? Yes, -2. Why? Because it's a decreasing acceleration. It's very tricky. Find the car speed after 12 seconds from the using brakes. Here, we have V1 80 meter per second. Acceleration -2. Why we have to write negative here? There is no negative here in the question because it's a decreasing acceleration, negative acceleration. We have to add negative, okay? V2 equal what that I want to get, and time 20 seconds. If I want to get V, we have to start from acceleration V2 minus V1 over delta t. So -2, which is acceleration, equal V2 minus 80 over 12, and then we calculate the V2 equal 56 meter per second. Thank you, dear students.